Let's take a look at section 5.5, special products. So here we want to start with some definitions. We want to start with a binomial sum definition. A binomial, this is a binomial in which the two terms, so a binomial has two terms, and the two terms are added when you have a binomial sum. The binomial difference is a binomial in which one term I meant to write the word term here, is subtracted from the other. So conjugates are a binomial sum and a binomial difference. So we just defined both of these above, that are made from the same two terms. All right, so some of the special products we want to talk about. The very first one is the square of a binomial sum. So notice that when you multiply a binomial sum, you're actually squared, the square of a binomial sum, you're actually multiplying a plus b times a plus b. So you have to use the distributive property. Notice a is multiplied times a plus b. So that's the a and I'll color code this too. So this a is multiplied by the second polynomial, a plus b, or binomial. And then this plus b also has to be multiplied by the second binomial. Now notice the two binomials are the same. Remember, squaring means to multiply something times itself. So we get a times a plus a times b. Plus b times a plus b times b. So notice the middle terms are both ab. We can multiply in any order. So we put the variables in alphabetical order when we're multiplying them. So notice that's where this is coming from, and the two middle terms are identical. So we get two ABs. So in other words, if we recognize this as a pattern, then we know as soon as I see I'm squaring a binomial, I know I'm going to get an a squared plus a 2ab plus a b squared every single time. So I can use that fact to save myself some time. In this case, my a is x and my b is 5. So this winds up being x squared. 2 times 5 is 10 plus 10x plus 25. 5 squared is 25. So that's what the square of this binomial sum gives me. So instead of me going through all of these steps that I've written up here, every time I have a binomial sum, since it's always going to have the same pattern, I go straight to the pattern and save myself all of these steps. That's the benefit of recognizing a pattern. All right, here's another binomial that's being squared. So we're going to have a squared plus 2ab plus b squared. Now a is 2x and b is 3y. So I just make use of the fact that I know, even if I did go through all of these steps that I've shown you here, I've shown you 4 steps here, what's going to result is a squared plus 2ab plus b squared. So the square of 2x is 4x squared. 2 times 2x times 3y is 12xy. And the square of 3y is 9y squared. So that's my final answer on that one. 4x squared plus 12xy plus 9y squared. Next, we want to look at the square of a binomial difference. Now remember, to square a minus b means to multiply a minus b times a minus b. But this is just where I'm going to use the distributive property twice. So this is a times a minus b minus b times a minus b. So this is a times a minus a times b minus b is multiplied by a, and minus b is also multiplied by minus b. And that gives me a squared minus ab minus another ab plus negative times negative is positive, b squared. So notice this is always going to result in a squared minus 2ab plus b squared. That's always going to be the result. I can go through these 4 steps every time if I want to, or I can use the fact that this is always going to have the same pattern. So let's take a look at a couple of examples. So let's square x minus 4. And let's make use of the fact that this is going to be a squared minus 2ab plus b squared, where a is x and b is 4. So I'm always going to have this pattern result if what I'm doing is squaring a binomial difference. So I get x squared minus 8x plus 16. So that saves me some time. Here's another example where I want to square the binomial difference 4x minus 9y. So again, I'm going to have an a squared minus a 2ab plus a b squared. A is 4x. B is 9y. So this is 16x squared minus 72xy plus 81y squared. That's my final answer on that one. So the square of a binomial difference will also always have a specific pattern. Now another case is the product of conjugates. A plus B times A minus B. Or it could be written as A minus B times A plus B. Well, again, we would be using the distributive property twice. So A needs to get multiplied times A minus B, and positive B needs to get multiplied times A minus B. So I have A times A minus A times B. I have plus B times A and plus B times a negative B. So this turns into A squared minus AB plus AB. Positive times a negative gives me a negative, so a negative B squared. And the two middle terms are opposites. Negative AB adds with positive AB to give 0, and the pattern that results is this is always A squared minus B squared. So in other words, when I see that what I have is a different, what we call a product of conjugates, then I know the result is going to be A squared minus B squared. And in number 8, A is x and B is 3. So this is x squared minus 9. That's my final answer on that one. Now here I have another product of conjugates. 2x plus 5 is multiplied by 2x minus 5. So I want to use my result. I know that this is going to be an A squared minus a B squared. In this case, A is 2x, B is 5. So 2x times 2x is 4x squared. 5 squared is 25. So this is 4x squared minus 25. And here we have a little bit more complicated example where we have 4y squared minus 2m cubed times 4y squared plus 2m cubed. However, it's still a product of conjugates. And I'm going to get an a squared minus a b squared. But in this case, a is 4y squared and b is 2m cubed. So when I square 4, I get 16. When I multiply y squared times y squared, I get y to the 4th. When I square 2, I get 4. And when I square m cubed, I get m to the 6th. So remember, when I'm raising a power to a power, the two exponents get multiplied. So 3 times 2 is 6, is where this exponent of 6 comes from. 2 times 2 is 4. It's where that power of 4 comes from. So this is my final answer. So in each case, I save myself some time if I use the pattern that I know will result.